Hey everybody, and welcome to lesson number 2, working with fractions. If you know anything about me, you'll know that I much rather see fractions than decimals. Why? Because decimals a lot of the time are not as accurate. We usually cut them off someplace, or we show like a bar showing that they repeat and go on forever. I don't like that. I'd much rather see a fraction. It's a lot more accurate, in my opinion. So we'll be working with them a lot. They're not that bad. In fact, you just have to practice a little bit. Okay. First, we're going to look at addition and subtraction. Here are a couple of rules you might want to remember. You can write them down. Right. First of all, any whole number can be written over a 1. For example, this 8 we can rewrite as 8 over 1. Right. That's going to help because the next couple of things. Number 2, we must have the same denominator on all terms, right? That 8, we want to see the denominator so that we can go to the next thing and see if we have the same denominators on all terms. Here we see that we do. And third, if the denominators don't match, we need to multiply by a fancy 1. I call it a fancy 1. Why? Well, think about it. When you multiply a number by 1, it doesn't change, right? It stays the same. So what we're doing is multiplying by a 1, keeping the number the same, but we need the denominator to change. So when we multiply by this fancy 1, it's keeping the number the same, it's just going to make it look different. So it's a nice trick that we can use to make sure that our denominators match. By the way, why is this considered a 1? Because we have a number being divided by itself, right? We have the right amount of parts to make a whole. That's 1. Okay, so you'll hear me reference a fancy 1 quite a lot throughout the year. So let's take a look at a couple of examples. I'll leave these up here for us to reference. Our examples are down here. If you want to take a second to write them down before I begin, that's up to you. So let's start with the first one. We have 2 over 3 plus 5 over 3. Our denominators, in fact, are matching. So the denominator should stay the same in the end. All we have to do is add the tops, the numerator, 2 plus 5. That gives us 7. So 7 over 3 is our answer. Next, we have 9 over 4 plus 3. Well, as I mentioned, we can rewrite this as 3 over 1. And we can see that our denominators don't match. So we've got to use this fancy 1 trick. In order for this 1 to become a 4, I'm going to have to multiply it by 4. Alright, 1 times 4 is 4. That's great. But in order for this to be a 1, I need this to be a 4 over 4. So this is our fancy 1 that we're using here. Right, so it doesn't affect the 9 over 4 quite yet. But here we have 3 times 4, which gives us 12 over 4. Now we have matching denominators. Now we can add. 9 plus 12, well, that's 21, and our denominator stays as 4. Our next example, that's a 5, kind of came out a little blurry, but we have 2 over 5 minus 3 over 4. Well, these denominators don't match, so I'm going to multiply using the opposite terms. So if I make my fancy 1 over here as a 4 over 4, and over here I make my fancy 1 a 5 over 5, right? I'm guaranteed to get the right number now because it's going to be the same thing, multiplying, right? 5 times 4 is going to be 20, no matter what order we have them in. So here we have 4 times 2, which is 8 over 20. And then we have 3 times 5, which is 15 over 20. And if I do 8 minus 15, well, that's negative 7 over 20. By the way, you could put that negative in front. I usually do, but it doesn't really matter in this case. You could put it there if you wanted to. Alright, the next couple. Here we have 3 numbers all adding, but you notice the denominators don't match on any of them. So if I want to think about it, the least common multiple that these all share would be 12, right? That's the least common multiple out of 2, 3, and 4. So I need to somehow make these all become 12s. Well, if I do 1/2 times 6 over 6, that's going to give me 6 over 12. I like that idea. If I do 2/3 times 4 over 4, that'll give me 8 over 12. And finally, if I do 3 over 3 for our final fancy one, that'll give us 9 over 12, right? So I had to think about the least common multiple, but once I found that, I just had to use what would that give me that least common multiple? What would I have to multiply by? And that's what we made those fancy ones up with. Now we can just add 6 plus 8, that's what, 14, plus 9, that gives us 23 over 12. And finally, we have a little bit of mixed subtraction and addition here. It doesn't really matter. We're going to be able to do it all at the same time anyways, as long as we have matching denominators, which right now we don't. So again, we're going to think of least common multiple. Least common multiple between these three would be 15. So I'm going to have to multiply the first one by a fancy one of 15 over 15. 5 times 15, let's see, 30, 60, 75 over 15. Here, I need to multiply by 5 over 5. And here, I'm going to have to multiply by 3 over 3. So this didn't change, right? 75 over 15. That's fine. Here, we're going to get minus 20 over 15. And then finally, we get plus 3 over 15. Alright, now we're going to do this just in order, going straight across. 75 minus 20 is 55, plus 3 is 58 over 15. Okay, so yeah, we did a couple of things throughout each of these problems. I took them step by step. So think about these rules, okay, these examples. Reference these ones if you need to, but I would like for you to try these three at the bottom. Pause the video and resume it when you're ready to check your solutions. Alright, let's check it out. You should notice that here we don't have matching denominators, so we're going to have to multiply by some sort of fancy 1. In the first case, 4 over 5 will multiply by 2 over 2. The second half will multiply by 5 over 5. Hopefully that's what you chose for your fancy ones. That will give you 8 over 10 minus 15 over 10. 8 minus 15 is negative 7. All over 10. How'd you do with that one? Get the right answer? If not, right, go through, check, see what you did wrong. Second problem. Well, I'm going to right away, I'm going to put a little 1 underneath that 4. In order for the 1 and the 2 to match, I'm going to have to multiply by 2 over 2. So I have 3 over 2. This is going to give me 8 over 2. And when we add, we get 11 over 2. And finally, well, none of those match, but I remember from an earlier problem, the least common multiple would be 12 here. So if I do 8 over 3, I'm going to have to multiply by 4 over 4. When I do the 1/2, I'll have to multiply by 6 over 6. And finally, the 1/4 by 3 over 3. Right? Those are going to give me the fancy ones and the denominator of 12, and they'll all be matching. So 8 times 4, that's what, 32 over 12. 1 times 6 is 6 over 12, and 1 times 3 is 3 over 12. 32 minus 6 is 26, plus 3 is 29. So we get 29 over 12. Again, check through them if you got them wrong. Right? Go through your own work and see where you may have made some errors. Quite honestly, I really think that you should write out your work so you can actually check through this stuff. It makes it a lot easier. Alright. Next part of our lesson is going to focus on multiplication. So here are a couple of rules you might want to write down as well. For multiplication, we're going to reduce first if possible. If we don't, it's okay. Hopefully we'll notice it later, but that will hopefully cut down on some work. Second, we're going to multiply straight across, right? Numerators, numerators, denominators with denominators. That's really it for multiplication, right? Try to reduce first if possible, and then just multiply straight across. If you don't simplify first, it's okay. Hopefully you'll see it later. I'm going to do that right now, though, right? I see two even numbers, right? 2 and 14. I can divide both of those by 2. That becomes a 1 here, and now I can just multiply straight across. 7 times 3 is 21. 5 times 1 is 5. Right? By reducing first, I made sure that I had a simplified fraction. Here our multiplication rules are going to be the same, so a negative times a negative, those will actually just eliminate. And then let's see. 6 divided by 2 is 3. 8 divided by 2 is 4. I did that because they were both even. Now I can multiply straight across. 3 times 1 is 3. 5 times 4. That gives us 20, and we get 3 over 20 as a result. Pretty straightforward. Just keep in mind your multiplication rules with negatives and positives. Try out these two problems right here. Pause it and resume when you're ready to check. Alright, let's see how you did. Hopefully you noticed that 21 is divisible by 7, so we can cross off those right away. And next we have 8, which we can divide by 2 into 4. 6 can become a 3. And now we multiply straight across. You should have gotten 9 over 4. Now if you didn't reduce all of that at the same time, or maybe you waited till the end for your reducing, that's fine. Did you get 9 over 4? That's the big question here. And finally, your second one you need to try on your own. Let's see, if I do 9 divided by 3 will give me 3. 12 divided by 3 will give me a 4. And then let's see, 4 divided by 2 is 2. 10 divided by 2 is 5. So we reduced everything. Now we just multiply across. 3 and 5 is 15. 2 and 4 is 8. So 15 over 8. Again, check out how you did. Hopefully you remember to show your work, making it a lot easier for you to check to see what you did right or wrong. Next, division. A lot of people that I talk to nowadays use something called KFC. It makes me hungry to think about it, to be honest with you, but it's not anything to do with chicken. It means keep the first term, flip the second term, and change the division into a multiplication. That's what KFC stands for. So I guess that helps people remember keep, flip, change. I always just remember, just take the last term and flip it. Okay, and then we multiply. We're going to remember the same rules we did with multiplication from before, reduce first and then multiply straight across. But before we do that, we have to keep, flip, and change. Right, so my 12 and my 7 will stay. This will change into a multiplication, and then I just have to flip this upside down, giving me 5 over 3. Now I can reduce, right? 12 divided by 3 would be a 4, and that 3 goes away into a 1, and now we multiply across. 4 times 5 is 20, 7 times 1 is 7, giving us 20 over 7. Here, 22 over 5 we keep. We flip 15 over 2, and then we change division to multiplication. Now we reduce. I see 5 and 15 can reduce into 1 and 3. 22 divided by 2 is 11. And let's see, we got 11 times 3, which is 33. 1 times 1 is 1. Hey, we got 33 over 1. That actually will reduce to just plain old 33. Right? If we don't need the fraction there, as much as I love fractions, if we don't need it, get rid of it. Right? Keep it as just a whole number. How are we doing so far? 15 minutes in. This is a long one, but it's almost done. I want you to try these couple ones out on your own. Pause that video and resume it when you're ready to check. Let's see how you did. You want to keep 18 over 11 and flip 22 over 9, and then whatever reducing you can That would have given you 4 over 1, which is just plain old 4 for the first one. Okay, second problem, I'm going to keep, well, actually, if I see this double negative here, I know that those are going to eliminate. We'll keep 16 over 10 for the time being. We'll flip 5 over 12, and then we'll reduce. I get a 2 and a 1 with that. I get a 4 and a 3. I can continue to reduce here. That's going to give me 2 over 3 as a final solution. Again, you don't have to do it in this exact order, except obviously the keep, flip, change, you do have to do in that order. But as far as the reducing, that's up to you how you reduce. So just make sure you get to the right number. That's the big goal here. Finally, we're going to look at mixed fractions. We want to write them as improper fractions. If you notice throughout this whole video, I had improper fractions, right? I had 17 over 3. I don't think that was actually on there, but you get my idea, right? I had a higher number on top of a lower number. So we don't want this mixed look, mostly because it's kind of confusing to work with. As you saw, our addition, multiplication, division, subtraction, all those rules, they worked with improper fractions. So we want to work with improper fractions. Well, what happens if somebody gives you a mixed fraction? You know, like if you go out to the store and it says 2.5 pounds, right? I get it. They're all over the place. So let's work on changing mixed into improper. And here's how you do it. You're going to multiply the denominator with whatever that coefficient is. Then you're going to add the result to the numerator and rewrite it over the original numerator. So it looks like this. Here's our original mixed fraction. I'm going to multiply our denominator times our coefficient, PB, and then I'm going to add it to A and write it all over our original B. Okay, so that little formula right here, if you know it, you know it. If you don't, write it down. Let's try it with a couple of these examples here. We're going to do 3 times 9, which is 27, plus our original numerator of 2, rewrite it over our original denominator, and then we can add those together now, right? 27 and 2 is 29 over 3. Our next example, 4 times negative 5 is negative 20, plus 3, all over 4. Negative 20 plus 3, well, that's negative 17, all over 4. That looks kind of weird. That's a 7. So I have 2 for you to try. That's negative 10. 5 over 7 is your first problem. If it's kind of tough to read, try those out and see how you do. All right. 7 times negative 10, I'm getting negative 70 plus 5 over our original denominator. If I add those, that gives us negative 65 over 7. Our second problem, 5 times 3, that gives us 15 plus 4 all over 5. 15 plus 4, that's 19 over 5. How did you do with those? Right? Again, it's not a lot of work to show, but showing it helps because then you can check to see what you did wrong. Finally, if ever you have to use decimals, you'll know because you'll be told in the instructions to round to the nearest whatever. Okay, so here's how rounding works. And I'm going over this because sometimes people just aren't sure. Right? If you have any place, right, you want to look at the place after where it's asking you to round to. So if I need, let's say, 2 digits, I want to look at the third digit. Okay, and if it's a 0 to a 4, we don't round. We just get rid of the rest of the information. If we have a 5 to a 9, that's when we round that number up. The only time that we're going to do this is if you see me say round to the nearest blank. Okay. By the way, if you have to round up and your number happens to be 9 that rounds up, it becomes basically a 10, right? Which means that your the place that you're rounding to becomes a 0, which we have to write and show, and then you're going to carry a 1 over to the next place. Hopefully there's an example of that coming up. I don't remember if I made an example of that, but hopefully this isn't the first time you ever rounded stuff. Anyways, as a reminder, okay, we have a couple of places that we want to keep track of, right? We have a 0 placeholder and a decimal. Your first place is the tenths. Next place is the hundredths. I put some dollar signs underneath here because that's where money rounds to. So anytime we're working with a money problem, you need to put the dollar sign, and we want to keep in mind the hundredths place. Then you have thousandths, 10 thousandths, 100 thousandths. Okay, millionths would be next. Keeps on going. So let's take a look at a couple of these. What we need for this, though, would be a calculator. So if you have a calculator, take it out. Your phone calculators will work perfectly fine. Right? They want us to round to the nearest thousandth, so that would be, let's see, 1, 2, 3, but I need to look at the fourth to figure out what I need to round to. So I'm going to do 31 divided by 18, and let's see, it gives me 1.72222 repeated, right? 1.72222. But this said to round to the nearest thousandth, so I got to look at the 10 thousandths, which would be the 1, 2, 3, 4th place. So 1, 2, 3, 4th place, and then I got to make a choice, right? Between 0 and 4, it says that we don't have to round. We just get rid of this stuff here. My answer would be 1.722. Second problem, 5 over 12, right? Clear out the calculator. 5 divided by 12, and what it gives us here is 4.66666666. Okay, they wanted it to the nearest hundredth, so we've got to look at, let's see, 0.4166 repeated, right? Well, I need to look at the third spot, the thousandth, to decide what to do at the hundredths place. It tells us to round up, right? So our answer, that 1 rounds up into a 2. It should be 0.42. Okay, so I have 2 more for you to try. These are the last ones of this video, so try them out and check your answers when you're ready to check them. Alright, if you did 13 divided by 16, they wanted you to do the nearest 10 thousandths. I don't actually think that would work, because I don't think they give you any more decimals after that, right? 1, 2, 3, 4, and then the 10 thousandths. So there was no 10 thousandths place, right? So we don't actually have to round. This is our answer. And let's do the next one, 21 over 6. And I know it's going to be a negative number because I see that negative here. We'll just keep it. 21 divided by 6 is, whoa, 3.5. I did not give you guys good examples to round with. Ooh, poor job, Mr. Marchetti. Why don't we try one real quick that you can round? Why don't we do something like round 2 over 3 to hundredths. Okay, try that one. Last one, I swear. I'm sorry, the last 2 I gave you didn't have any rounding necessary. So do that one real quick. 2/3. I'm getting 0.6666 repeated, right? The hundredths would tell me to look at the third place. It says to round up, so 0.67. I am truly sorry about that last couple there. I didn't bother to check before I made the video to see if they needed any rounding. Oops. Well, that's a 24-minute long video. I think that's long enough, and we went over everything that we need to know about fractions and decimals to make us successful in this class. See you at the next video.